Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
All right, thank you. Be seated. All right, we are now moving on to our next unit, that is unit 11.3 on electricity. We've studied measurements, we've studied force and pressure, and this time the unit will be on electricity. Now, first topic that we will study on electricity will be looking at the circuit symbols. Now, the symbols are used so that each one of us can understand electricity more better. And also these symbols are used so that everyone, let's say all around the world, can simply recognize those, especially the diagrams and also the symbols. Now, they also help us to, identify what that comes in, especially at this stage when we are going through and reading, studying about electricity. These symbols will be able to help us to understand that subject more better. Right, firstly, we will go through, I will be asking you to nicely roll up, let's say 3 columns in your exercise books. Pilot teachers, you can also ask your students to nicely roll that up. And then we'll be going through and then looking at this circuit symbols and also the name given to each one of those symbols with their explanation or definition and the function of each of those symbols. All right, so quickly go through, roll up columns, 3 columns in your exercise book, and then we'll go through each one of those. All right, we will now go through looking at the first 3 symbols that are used. All right, the first one will be 2 cells in series, and the diagram is shown on the left, and on the right you will find the name or the explanation for each one of those. So quickly go through and then write, but on the last column you have no explanation, so you just leave that one out. I'll give you as part of your exercise. Okay, you can go through and then define, explain what a cell is, and then you can write down in that column. So you just write on the first 2 columns, that is the diagram and 2 cells in series. In the next column you can write that. The third one, leave it blank. Right, when you are going through, you find that is the positive and the negative end of the tri-cell. So simply when you are connecting the tri-cell, the electrons will have to flow from the negative end towards the positive. But you will find that the current will be in the opposite direction. The current flows from the positive to the negative. So that is exactly how you can draw. So you have 2 cells which are in series, right? The longer stroke shows you the positive end, while the smaller or the short one is simply a cell. All right, here is the next. Okay, you have a fixed resistor and also a variable resistor. All right, for a few fixed resistor, you can have it as a, sometimes you call it as a fuse. Okay, this one is a fuse. Now this one is almost like it is, but it varies the current that is passing in the circuit. That is why we call it as a variable resistor. For example, if you have to increase the current, what will happen? All right, what kind of work that electrical energy is doing will have to increase. All right, we just go through, copy this one, and then I will show you the examples of each one of these later on. Right, by now everyone should have finished. I will now give you the next diagram. Now to the next. Okay, in explanation of that, especially when you are looking at this filament in a light bulb, right, simply you have a glass casing which is surrounding this. Now, because this is a filament which is made of tungsten, which is a very high resistance wire, and also it has a very high melting point. That is the reason why you find that it is coiled and left inside. I'll show you this later on. But anyway, you have a filament that is running in that, and that filament is the one that normally glows and then it gives off light because it has a high melting point and also high resistance. Okay. Right, those are the other symbols of electrical circuit. The first one is a switch, and then you have wires that are crossing but not touching, and then you have galvanometer. And I'll show you this, the example of each one of these later. All right, sometimes for a fuse you may see symbols like this. All right, they have to mean the same thing. A fuse can be seen that way, and then you have a milliammeter, which is shown in that using that symbol. Okay, a small m and then A. Or sometimes you'll find that for wires, especially when they are touching each other, it'll be something like this. Right, this time the one that you see are wires that are crossing but not touching. But if they are touching, you'll be looking at something like this. Okay, wires that are crossing or touching each other. Now, sometimes you may see symbols like this. Okay, this is the head wire. Very good. Okay, this is the head. Okay, those are some of the symbols that you may see. All right, for each one of these, this is your activity. When you are going through and copying this activity, I'll be also passing this one around so that you have a look at them. Okay, for the first symbols and the diagrams, I'll be showing you what physically these things that we are mentioning are. All right, I will show you, I'll pass this one around, but firstly I will have to show this to the pilot students, and then okay, I will pass this one so that you have a look at it. All right, the first diagram and a symbol that we saw was on cells. Right, you find that there are different types of, this is a 3D cell, and you find that they come in different sizes. All right, so this one is a large one, and then you have the medium one, and also the smallest one. Okay, so they come in different sizes. All right, so what is the function of this one? What is the function of the cells? How can you explain them? It is a, is this a device? It is a, okay, it is a source. right? It is a source of electricity or power. But you can simply explain it in other terms as a device that can change chemical energy to electrical energy. So I'll pass this one around. You can have a look at it. That's the first one, explanation. So on that cell, and given a symbol, you can write the explanation of that. For the others, you were already given, so you just go through, you try, maybe you can discuss among yourself, and then you come up with what each one of those symbols are for. Okay, write them down, and then we go through and have a look at them individually. So I'll pass this one around. Okay, maybe you can pass that around and then have a look. All right, the next is a wire. Okay. The function of this is to, because it is a good conductor of electricity, that will allow electricity to simply pass through the wire. So this is an example of a connecting wire, and it is made up of copper. Okay, copper is a good conductor of electricity. All right, if you can pass this one around too and then have a look at it. The next one is a fuse. But you can simply construct a fuse from a high resistance wire. Okay, I don't have a fuse to show you, or fixed resistor. Okay, a fixed resistor or fuse. But this time I have a variable resistor. Okay, what happens is that it has to vary the current that is passing in the circuit. Simply by moving this one up or down, you will cause the current to increase or decrease in the circuit. So this is a variable resistor. You can go through. When it comes to resistance, we will know more about this instrument. Okay. All right, the next one is a light bulb. All right, you can see that this one is quite, it's kind of invisible inside. You cannot see what is inside. So what do you think this is? Okay, this is a lamp. This is a lamp because it has some kind of chemicals which are in place. Probably we may have contained argon or something like that. Now the reason for this is that it has to prevent the filament from burning out. Okay, so this is a light, a lamp. Now we also have the bulb here, the one that was shown to you earlier on that picture. All right, this is a real light bulb. Okay, if you can look through, you'll find that it has a filament, right, which is made of tungsten. Simply that tungsten is a high resistance wire. All right, these ones are the, you have this one which is a voltmeter, and that is an ammeter. So you explain what they are used for, the function of each one of these. Okay, so I will pass this one around and then you can have a look at it. All right, on my hand I have a What is this? It is also an ammeter, but this time you find a small sign or symbol that is on the side. It is a micro ammeter. Why do we call it micro ammeter? Sulaiman. Okay, because it measures very small amounts of current, or very small current that is passing in a circuit can be measured. And also I have an instrument which is known as an, okay, this one is a galvanometer. Okay, what is the function or the purpose of that galvanometer? Okay, so you write down on the columns that you have quickly, and then we'll go through and then have a look at each one of those individually, right? So pass this one around, have a look at them. All right, here comes question number 2. Right, some of you may be wondering whether that is the same thing as the one that are hanging on the ceiling here, the lights. Right, these ones are basically the fluorescence tubes. Okay, examples of the light bulbs that you are passing around are the incandescent light bulbs, but these ones are the fluorescents. Okay, looking at these fluorescents, they contain also a chemical in there. Simply it is mercury vapor that is in there. So what happens is that at the terminals where the current will be let in, when this current passes through that chemical, it causes the electrons to become excited, and then they have to give off light at the same time, giving ultraviolet lights as well. So that is especially for these fluorescent tubes. But these ones, you have filament which are in place. So the filament is simply a high resistance wire, and they only get hot, close, and then give off light. Okay, many of these applications can be seen especially on elements of cooking stove. If you are concerned about this resistance, especially high resistance wires are being made. So the nichrome is simply a high resistance wire, and you can find it especially on elements of electric stoves. Okay, because they have high resistance, they cannot allow the electricity to pass through quite easily. So they simply become hot to a certain point. Okay, are you finished with these 2 questions? Now I will give you the next question, that is B to question number 2 and third question. Okay, have you finished the function of the... Okay, quickly go through. I'd like you to do question 1 quickly. Describe the function of each one of those symbols that were given to you earlier. You finish? Write the function of this one here. Okay, you finish, just finish. Go through, even if you have to make mistake, I will.
The resistance in the B, will be each one is in a different parallel circuit, or two of them on the same?
On the same circuit, on the same circuit. Right, question B, only the same circuit, but you can draw each one of those symbols in. Okay. Let's see, who was the one who did not go through yesterday to answer the questions? Okay. 1, 2. Okay. For the first symbol and the second symbol, we go through. First one. What is? Okay, this one. Okay, what is a cell? You have to explain this. And then. Okay, for this resistor. Yeah, this one should be resistance, and you go for the cell. No, wires and the. Okay, you go for the wires explanation of a wire. Okay, you go for the resistor. You go for the fixed resistor. Okay. Variable resistor. Okay. And variable resistor. What is it? An ammeter. Variable resistor, and then you have the ammeter. Is it after that? Bulb. Okay, bulb. You go for the bulb. Explain the bulb and all this. Okay. And you go for what is next after that? Ammeter. Okay, voltmeter will be you. Voltmeter. Okay. And you have a galvanometer. Okay, question number, the last question would be you. The last question would be you. And second question would be you. Second, A, B, and C. Okay. Question number 2. Question number 2, A and B. That's right. Okay, you finish copying down the question. Okay, question number 2. Okay, question 2. This is question 2. You finish copying question number 2A. And question number 2B and question 3. Finished? Okay, quickly here. Okay. You get ready as you answer the question. Pass that mic over here. You answer the question, pass the mic over to the second person. Right, question number one, we'll just go through each one of those components. Right, they are sometimes known as the components of the circuit. Right, the first component is a cell, and that is, okay, Samantha, you explain what or define and explain.
A cell stores power and it basically converts chemical energy to electrical energy.
Okay, very good. So, a cell is a source of the power or simply electricity, and we can call it as a device. All right, it is a device which will convert chemical energy to electrical energy. Good. All right, for second one, that is connecting wire.
The job of a connecting wire is to basically conduct electricity, and it provides a route for electricity to travel. Normally, copper wires are used because it's a good conductor.
Okay, good. A connecting wire is a good conductor of electricity, and that allows electricity to flow through quite easily without any resistance. So we can simply say that a connecting wire should be a low resistance wire. Okay, we will now move on to the next, which is the light. Okay, next. Okay.
A bulb is a device which converts electric energy to light energy. By glowing, it indicates that electric current is flowing in the circuit.
Okay, a light bulb. A light bulb is simply a device which which is made of a filament, but this time it gets hot and then glows to give off light. Okay, that is especially for light bulbs. So if you have something like that for the first one, that is a cell which converts chemical energy to electrical energy, and then you have a connecting wire made from a metal which can conduct electricity well. All right, that is for the first two. Okay, that is for the light bulb, which is a device with thin wire or filament which will converts this electrical energy to heat and also light. Okay, what is a resistor? Okay, who was given the okay, that is for the fixed resistor. Okay, fixed resistor.
Fixed resistor is a device that opposes the flow of currents. It's in opposition to the current. It stops if there's too much current flowing, it slows down the current flow. So it's called a resistor. It's usually made from alloys of carbon or from carbon.
Okay, good. Especially a fixed resistor, from that definition, any device is a thin wire or a filament which converts electrical energy to heat. Right, that is a resistor. Or sometimes you may find a fuse. Simply they have to melt because it is a resistance wire. It melts off, disallowing the current to pass through. Okay, that is especially for a fuse or resistor. Okay, from that definition, All right, the next one is a variable resistor. Uh,
The variable resistor is a device which allows the value of the resistance to be changed to provide a range of values for current or voltage.
okay. It controls the current in the circuit by varying the resistance. That is why we call it. Now the example of that is a rheostat. A rheostat is seen on the desk over there. That is a variable resistor. All right, we will now go on to the lamp has been given, probably the ammeter and the voltmeter. Okay, Malcolm. Okay, use the ammeter.
An ammeter is a device used to measure electric current.
Okay, it measures the electric current or simply the flow of electrons. Okay, and finally to
Voltmeter is a device used to measure voltage or potential difference.
okay, it measures the voltage in the circuit. Simply, voltage is simply the electromotive force or force that drives the current in the circuit. So a voltmeter measures that. All right, we will now go to the switch. Right, you will have to turn off. All right, switch is there to turn off the circuit off or on, or sometimes a name given to these will be open and close the circuit. That is basically the function of the switch. And then you have a galvanometer which will measure very small current in the circuit. Okay, so a switch open or closes the circuit, meaning that it allows or disallows the current to flow through. Sometimes you have or term the volts given that will be open or closed switch. And then you have the galvanometer which measures the that measures very small current in the circuit. All right, we will go to the last three questions quickly. Those students who were told to do that question, you can come up quickly and then draw your circuit, three of you, and then one of you can explain each one of those questions. All right, for the first one, question 2A. Okay, 2A to B, and you'll be, who is 3? Question 3. All right, just remove that one and then you can quickly go through. There.
Can I draw this parallel circuit? Sorry, series circuit.
Which question is that?
Third one.
draw a. Yeah.
Yes, so this is circuit in series circuit rather. These are the cells, 3 cells in series, a resistor. It can either be this or the zigzag one, and an open switch.
Okay, good. So that is the first question. Question number 2A. Choose.
This power circuit. These are 3 dry cells, plus the 3 resistant wires, plus the switch.
Okay, the last percent, that is quite correct.
Second question, maybe the power circuit can it be connected like this also? I mean, can it be connected like this or like that?
Okay, you
This
asked
is a
to
series
draw
circuit
in
with
parallel.
3 cells,
It can be like that too.
a switch, a
If you want to.
resistor, a
But
bulb,
otherwise,
and an
this is the
ammeter.
source, and then you can have it down there. Yeah. Yeah, resistance can be down there. All right, as long as you understand the diagrams and also the symbols that are used, you can always draw the circuit more correctly. Now looking at the first one, that is quite correct. You can use the other resistor. Okay, a resistance can be as a fixed resistor can be this one, or you can use that one. Okay, this one is also a resistor. So whenever you find something like that, that is a resistor in circuit. Right. As we come to our next lesson, or when we study in our next lesson, we'll be looking at the some of the units of this and how we can calculate each one of those resistance, even the current and also the voltmeter. All right, that is in our next lesson. So with that, our keyword for today will be electrical symbols. Good afternoon, pilot teachers and students. Good afternoon, class. Right, thank you. You may sit down. Our keyword for today will be electrical symbols. Good afternoon, pilot teachers and students. Good afternoon, class. Right, thank you. You may sit down.